Okay, welcome to my CCNA guide. This is on chapter 4. This is easy subnetting. That's always a funny concept. So in this chapter, we're focusing heavily on IPv4 and IPv6. We're going to be describing the operations necessary for using both private and public IP addresses for IPv4, essentially NAT. So in chapter 3, TCPIP, you learn how to define valid host ranges using a class A, B, and C network. That way we could figure out which is the network, which is part of the host bits, things like that. The interesting thing is you are defining only one network. What happens if we need to define larger networks, or if we have to define variable length subnet masks? So multiple networks connected together is a concern. Will this network function the way it is? One of the things is we have to separate the different networks. The interesting thing is, let me get my pen out. If this may be a slash, it looks like everything is in groups of 32 bits. So slash 27 maybe. If that's the case, because if we have our 8 bits, dot 8 bits, dot 8 bits. So in the fourth octet, 25, 26, 27. That will give us a block size of 32. That look horrible. So this could very rarely, this could be an appropriate network if we're using a slash 27. However, if we're using a slash 26, this isn't a valid network. So the subnet mask is very important. So to create a subnet, we'll start by fulfilling 3 specific steps. First, determine the number of required network IDs. Determine the number of required hosts per subnet. And we're going to use the information above to create the following: a unique subnet mask ID, a unique subnet ID for each physical segment, and a range. So if we are doing a class A network, we already know that we're only using the first octet. That will be our network. And everything to the right of our line will be our hosts. We're using a class B. The first 2 octets are locked in. The last 2 are able to be played with. And if we're using a class C, first 3 octets are locked in. So that's pretty straightforward. But what happens if we want to play with other networks? So we've looked at a slash 8, we looked at slash 16, we looked at slash 24. But we can manipulate them on mid-boundary. Normally what I tell people is these slash numbers is just how many number ones you have. So let's look at this slash 26. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Together with dots. 1, 2, 3, 4, 5, 6, 7, 8. So that is 24 ones. 25, 26. That means the rest are 0. What position is that last one in? Well, if we start on the right, when we just start with 1, we keep doubling. 16, 32. This last one happened to be in the 64-bit, meaning if we are looking at this slash 26, because we have 26-1, and the last one happens to be in the 64-bit section, our groups are going to be groups of 64. So if we do 0 to 63, 64 through 127, 128 through 192, and so forth. We know all of that because the position of that last one. So once you've already chosen the possible subnet mask for the network, we need to determine the number of subnets that can have. Essentially, we're asking how many subnets does our chosen subnet mask produce. In the previous slide, we have a /26. That would produce 4 subnets. 0, 64, 128, 192. If we had a /27, that should produce 8 subnet masks, and so forth. So let's look at an example for /25. If we're going to leave the first 3 octets alone, we're going to convert that 4th octet to binary. There it is. What position is that last one in? Happens to be in the 128 position. So that means we actually have the ability to do groups of 128. So it's be 1 through 127, 128 through 255. If we're looking at how many hosts we're going to be using, we actually are going to be looking at how many ones do we have? Sorry, how many zeros do we have? We have 7 zeros, so 2 to the power of 7 minus 2. And we're going to lose 1 for the ID, lose 1 for the broadcast. And that should equal 126. That's how we got that right there. What are the valid subnet masks? 0 through 127, 128 through 255. What will the broadcast address be? That'll be the last address. What will the network ID? That'll be the first address. Valid hosts are everything in the middle. So 0, 1 through 126. 127 is our broadcast. 128 is our ID. 129 through 254 with a 255 as our broadcast. So if we want a little cleaned up version of it, here we go. With this, we have a /26, which we know that's going to be, if we break this all down, we look at that last 1 position, that's in the 64 position, groups of 64. So that means we should have 4 groups, 0 through 63, 65 through 127, 128 through 191, 192 through 255. Again, if we do a /27, we're now looking at 1, 2, 3, with the rest of the bits all 0. We look at the last one, that's in the 32 position, so everything will be based off that block of 32. /28, that will be last one is a 16 position, so everything will be based off of 16. 29, same thing. 1, 2, 3, 4, 5. Everything will be based off of 8. /30, everything will be based off of 4. And that is actually our subnet in a nutshell. Check out my other videos for more details for subnetting, explaining how we got all of these numbers. Thank you.